Okay, hi everyone. Okay, as soon as you install Eagles and after that you use your student ID to register an account, you should be able to come into this page here. Okay, so from here you can actually look into projects, push it down. Okay, right click on project, you will have a new project here. So you can always open a new project when you're doing your stuff, and I can name this as Buggy project. Okay, so once you're done, okay, you click on it and right click on the Buggy project. You should be able to see a new. From new you can see schematic. Okay, so from the very start we will actually create a new schematic first. Okay, from this page, how do you actually add a component? Okay, very simple. Just go to add part here, click on add part. You actually open up a library like this. Okay, from the library you will see that there's a lot of things here. So how do you actually select the right component for you? Okay, let's start up by adding a resistor. Okay, from here you can actually see that there's plenty of different resistors that is available. You can just click and take a look. So maybe I just try this. Let's take a look at this. Open it up. Okay, so from here you can actually see that the component itself having a 7.5 okay mm's grid spacing, which is the length over here between. Okay, you can actually use the diagram here to see whether is it correct. Okay, then this is actually the footprint and this is actually the 3D drawing. Sometimes they do provide you with the 3D drawing, but not all the time. Okay, so this is actually the schematic diagram. Okay, so how do we identify whether this is correct or not? So let's look at the diagram. Okay, so usually we'll be using a quarter watt or a half watt. So for quarter watt is 6.8 mm, 6.8 okay mm apart for the length, and for the half watt will be about 10 mm. So to be safe, so we can actually use the 10 mm diagram. So let's see whether we can find a 10 mm one. Okay, I think this is suitable for 10 mm. Then the grid is 10. You can see from here the grid is 10. Okay, so let's add this. Okay, how do you add this? Very simple. On the right hand corner, actually you have a oh sorry, okay here. So by clicking onto the okay, you'll be able to come to here. Okay, as soon as you come to here, you'll find that you are able to place the resistor. Okay, so every time you click, you will actually duplicate one more resistor out. If you don't click, you won't have. But if you want one more resistor, you can click one more. Then if you do not want anymore, you can press the escape button. You will come back to the library. Okay, what other things that you want? Maybe LM3 sorry LM324. Oh, don't have. Sorry, one more time. LM324N. Okay, so for LN324N, you will see that there's actually 4 amplifier, okay, inside the IC, and the footprint is actually here. Okay, so by looking at the footprint, you will and the 3D drawing, 3D diagram, you should be able to know whether this IC is what you want. Okay, if this is the IC that you want, click on the OK button. Okay, and okay, for this is a bit different, where every time you put in, you'll be one operation amplifier. Okay, so if you click and you go one more, you'll see that there's a one A, 1B, and so on. So now if let's say I need one only, so I just click one, I click on escape. Okay. Then what else do I need? Another thing that is quite important will be the power supply. So you can type in supply and click enter. Oh, okay, there's plenty of supply here. Okay, so how do you identify the right supply that you want? You can drag it down and see supply 1. Maybe I need a 5 volt. Okay, so I click on the OK button here below here. Okay, 5 volt. And what else do I need? I need a ground. Okay, ground, this one. Okay, same thing, I click on the OK beside me, and I have a ground. Okay, so sometimes you also need a connector to connect onto the board. So how do you get a connector in? So looking at it, I can actually try phonics. I don't know whether I've spelled it correctly. Okay, phonics connector. So by clicking around, you should be able to see different connectors that's available. Okay, so let's look around for the right connector. I need something that is 2-pin. Oh, this is too much. Okay, let's see whether I get. Oh, this looks like what I want. Okay, and from here you can see the footprint of the diagram, and also from the footprint you should be able to see how big is the spacing. You should be able to get something like this. The one that we are using is 5.08, so this is 5.08, so it's correct what we want. Okay, so let's click on OK. Maybe I need a connector in and a connector out, so maybe I can put one here and a connector that's going out. Okay, so that's done. So when you press escape, okay, so you come back here. If you don't need anything else, you can just click on the cancel button here, so you'll end the adding component. Okay, from here, how do you actually join all the components together into a circuit? So you do have a net button here that you can use. Okay, so maybe here, from here, I will get my power that's coming in. Okay, then here, sorry, it's a bit too small for me. Already. Okay, let's zoom in a bit. Okay, from here to here, and maybe here to here, and here to ground, and this to this part here, and this to this, and the output. Okay, so wait a moment, the output is just behind me. Can I just take it out? So you can use the move button here. Okay, let me stand aside. Okay, click on, oops, sorry. Okay, move them out here so that I'm not blocking them. Okay, you can put them together or you can put them aside. Okay, go back to the net button and click here, click again to go one round, and this one maybe I can connect back to the ground here. Okay, so but I'm short of something. What am I short of? You will see that actually your IC actually needs a power supply, which is not available. How do I do that? Okay, so your IC power supply is not there, right? You can actually right click on this. Let's escape first. Right click on this. You will look at this invoke. Okay, from invoke here, you have a power supply. Okay, you can see that it don't always appear. Okay, upon request, so you click on, you will have your power. So you can actually place your power here. So it needs some power. So same thing, you go to net, click on this. Okay, go to 5 volt, and this can goes to ground. Yep, that's all. Okay, and your circuit is more or less done. Okay, so to clean it off, you can actually select this, delete. Okay, let's see whether the connection is connected properly. One more time, let's connect it one more time, just to prevent any wrong connections here. Okay, connect them together. So basically your circuit is actually complete. Okay, so there's other functions like you need to add value. So you can actually click on the add value. This is value. Oh, sorry, this is name. You can click on the add value. Okay, add the value for the resistor. So maybe this is 1K. Okay, and maybe this is 10K. Then you have actually add the value for your resistor. Okay, so once your circuit is complete, that's all for your schematic. You can actually save it here. Click on save. You'll ask you to save the name. Okay, for the name, maybe you can say that this is a sensor. Okay, save. Okay, so once you have this circuit here, next I'm going to teach you how to run a ERC. ERC is to check the connections of your whole circuit, whether it's all connected. If there's a connection error, it will actually prompt you anything that is not connected properly. So let's run the ERC now. Okay, for ERC you can click on this. It's on the next page here. Okay, let me bring this here. You'll see that there's some warning. So some of the warning are usually okay, and the only thing that you will need to worry about is the error. So if there's no error, that should be fine. Okay, so for this we are good to go. Okay, now I'm going to teach you how to actually add a library into the eagle file. So sometimes when you search for a certain component, you do not have that component, so you go to online and you search for eagle PCB footprint or something like that. So once you found the footprint, you have downloaded a file like this. So it's very simple. You just need to click. Okay, you just need to click on the file, drag it into the library, drop it in, and make sure you right click on the library and say use all. Then you will see that the library has a green dot here. The green dot actually indicates that the library is actually in use and you can use it. Okay, let's open up our schematic again. Okay, so let's open it, and from the schematic itself you can actually go and add the component. Remember, we add a RLC, so let's say we find a inductor. Okay, from here you can see that where the library is from. So our library just now that we have added is a RLC library, something like that. Okay, it's all here, RLC. Yep, all the inductors are here. Okay, so that's all for adding a library. Okay, after you have run your ERC, you'll be able to create your PCB board. Okay, so now I'm going to teach you how to create your PCB board. Okay, so next, what you need to do is to click on this green little button here. Okay, this button will actually help you to create your PCB board. Okay, so you'll ask you whether you want to create a PCB board from this schematic. Click yes. Okay, So what you have seen here is actually a PCB board. Okay, this yellow line is the outline for the PCB board. Okay, and the black color background will be the PCB board. Okay, so you can actually choose from the top layer and the bottom layer here, right on top here. Okay, and also from here you can actually move all your components in. But before you move your components in, okay, look at this button here, which is the grid button. Okay, the grid button is actually quite important. Okay, why do I say so? Okay, so click on the grid button. You will see that your diagram, the units that you have is in mils. Okay, so if you want it in mm, then change it back to mm, and this one you can change it to mm also. So from here maybe I can put 0.1 mm, and this one is a 0.1 of a mm. Okay, so next, okay, you can click on the move button. Okay, you can move all these component into it. Okay, so when you move, look at there's a cross right in the center of it. Try to click on the cross, it's easier to move. Okay, then next you can actually look into rotating. Let's say I want it upright, I can click on rotating. I click on it. Okay, you rotate, you click one more time, you rotate again 90 degree and click one more time. So maybe this is the one that I want. Okay, next, maybe I should move in my resistor. Okay, this resistor, let me take a look. Okay, maybe I should put it here. And the other resistor, maybe I can put it somewhere here. Then what about this? This actually the... Okay, let me see. Maybe I put this on top. And maybe I can put this below here. Okay. So next, the resistor is not really aligned properly. Maybe I want to change the orientation of the resistor. So click on it. Okay, this is good. Click. Let me take a look. Okay, maybe this is good also. Or should I rotate it some more? Yeah, maybe this is better. Okay, then you can actually move. Oops, sorry. Move it maybe upwards. And this one, move it here. Okay, this one I can actually compact it a bit more, smaller. And maybe this one I can put it closer also. So as long as you don't overlap the footprint, you should be safe. Or if not, you can actually put a bit of spacing in between. Okay, because sometimes the components is a bit big, and sometimes the component, you do have wires joining them, so you might need some space for them. Okay, so how do you actually join the wires? Okay, that's very simple. You go to this. Okay, select this. So the next thing that is important is that what you want. Okay, so you want it on the top layer or you want it on the bottom layer. So usually we'll choose the bottom layer. Okay, then next will be, oh sorry, you don't need to click this again. Okay, click on the bottom layer. Okay, you will see that the width. Okay, what is the width for? Okay, the bigger the width will allow more currents to go through. So if you do it in mils, you will see this in mils. Let's say I change the dimension back to mils. Okay, you'll see this in mils. Okay, so you can go online and do a calculation how much current you want to pass through that track, and you can actually calculate how big the track width is. Okay, the PCB board that we are using, the copper thickness will be 35 micrometer. Okay, so the thickness will be very small, but you can use that to calculate the width that you need. So maybe now I can choose, it's a very simple circuit, so I can choose maybe 24. Okay, and I can actually zoom in to this part here, okay, to do my connection. Okay, so bottom layer, okay, then the track width is very important. Okay, next you can actually connect them together. Okay, try to connect them with a angle, not a right angle but a 45-degree angle. Okay, so when you finish the connection properly, you should hear a ting sound or something like that, depend on your system itself. Okay, okay. Sometimes you might not want to route it inside the IC chip, and you want to route it outside the IC chip. Okay, okay, so my circuit is complete. Okay, so by clicking onto the circuit itself, you can actually see the net. Okay, or maybe I should right click, sorry, go to dimension property. Where's property? Oh shit, you cannot see. Okay, wait, let me try again. Go to property. You should be able to see the net. Oh, yeah, yes, it's a ground net. Do you see? It's a ground net here. Okay, so next, what am I going to do is that I'm going to create a ground network here. Okay, a red nest. Okay, red nest is actually quite important. Okay, so you go to polygon. Okay, create a polygon first. Okay, so what you can do is draw a polygon around the whole circuit. Okay, that you want to create the red nest. Okay, then it will tell you the red nest name, so you put ground. Okay, then next, okay, before you click onto the red nest, you can look into the spacing that you want. If you need a bigger spacing in between, so for easier soldering and all that, maybe you can change it to something bigger. Okay, then after this you can click on the red nest. Okay, so you can see that actually the whole circuit, right, is actually isolated. Okay, it's ground, except those tracks that you have that is not ground will be still connected. Okay, you can zoom in and see. Okay, you will see that the tracks that are not ground, they are all isolated. Okay, then the rest of the plane here will be ground. The rest of the plane here, okay, everything here will be ground except those that are isolated here. Do you see? Okay, so next I'm going to teach you on how to change the dimension for this PCB. Very simple, you go to this selection. Okay, select the line, just change accordingly to what you want. Okay, that's the simplest way to do it. Okay, and the last one is a bit too far ahead, maybe I can zoom out, click on it. Okay, and done. Okay, okay, some more, a bit more. Okay, yep. So sometimes you want to drill a hole. Okay, how to drill a hole? You do have this hole function. Okay, then you can see what is the hole size you want. You can actually change it back to mm, so it's easier. and you want to drill a hole. Okay, change it back to mm. Maybe you want a 3.2 mm hole. Okay, so you can actually drill a hole, drill another hole. Okay, this hole are for you to do your dimensioning or to hold the board onto something. Okay, or hold a spacer onto it. Okay, that's about it for now. Okay, next you can actually, next what you can do is that you can do a export. Okay, go to file. Okay, generate cam, say yes. Okay, all the files are generated here. Do you see? Okay, actually I do not need all the files, but it's okay that you provide me with all the files. Okay, so they will ask you what to change. Okay, then you just save it. Then after that, give me this folder. Okay, this file folder, that will do if you want to print out your PCB.